everyone, this is Inverse Trig Functions Part 3, and this is just to help you with the extra credit if you wanted to try it. So I'm going to just show two of these and then see if that should be enough help for you to complete those extra credit questions. So the first one is tangent of arc sine of x over 4. Okay, these are a little bit different than the ones we have been doing. And first I'm going to just write in that arc sine is the inverse sine. So remember that when we see inverse, we're looking for what angle has a sine of x over 4. And if you look at the unit circle, you're not going to see a sine or a y value of x over 4. So we're actually not going to use the unit circle for these questions. We're going to make our own triangle. And I'm going to put theta here. You can put it anywhere. But I'm going to basically construct an angle that has a sine of x over 4. So you want to think about the formula for sine in terms of SOHCAHTOA. So sine is opposite over hypotenuse. And so that means that x is the opposite and 4 is the hypotenuse. So here's my angle. The opposite is x and the hypotenuse is 4. So inverse sine, again, it's asking for what angle has a sine of x over 4, and we just created it to be theta, right? If you look at that triangle, theta has a sine of x over 4 because the opposite over the hypotenuse is x over 4. Sorry. So with the triangle that we have created, the angle that has a sine of x over 4 is theta. So that became everything that's in yellow right now. The angle that has a sine of x over 4 is theta, and then I brought down the tangent. Then you're still going to be using that same triangle. I'm just going to redraw it here. You have theta and x and 4. Now it's asking the tangent of that angle. And what is the formula for tangent? Opposite over adjacent. So we're going to use the opposite, which we know, but then we need the adjacent, which we don't know. So how would we find that missing side of the right triangle? We would be using the Pythagorean theorem. So I'm going to label this as B. And the Pythagorean theorem gives us x squared plus b squared equals 4 squared, right? And we're trying to figure out the adjacent side. So we're solving for b. And so we would move the x squared to the other side. We get b squared. Instead of 4 squared, I'm going to just write 16 minus x squared. And then what's the last step here? Square root both sides. So b is the square root of 16 minus x squared. So using the Pythagorean theorem, we found that missing side to be the square root of 16 minus x squared. And then we're ready to answer this question now. We're doing the tangent of theta. So tangent, again, is opposite, which is x, over adjacent, which is the square root of 16 minus x squared. And that would be our answer. Right? Remember that everything builds off this theta. So that's our reference angle. So this is opposite over here and adjacent down here. Okay, I'm going to just show you one more. The last one is cosine of arc sine of x. Okay, and then I'm again going to rewrite arc sine is the same as inverse sine. So we're always starting with this inner expression, and the inverse is saying what angle has a sine of x. Again, we're not going to use the unit circle because there are no sines or y values of just x. So we're going to make our own triangle. And again, we're going to construct that angle to be theta. So we want an angle that has a sine of x. What's the formula for sine? Opposite over hypotenuse. So remember there's an invisible 1 there. So this is the opposite and this is the hypotenuse. So opposite the angle is x and the hypotenuse is 1, right? And then again, the inverse is saying what angle has a sine of x over 1? That angle is theta in the triangle that we created, because the way we have it set up, the sine is x over 1. So the angle that has a sine of x over 1 is theta from our triangle, and then we need the cosine of that angle. So what is the formula for cosine? Adjacent over hypotenuse. And so if we label, this is theta, so this is going to be opposite, and this is going to be hypotenuse. And so if we are looking for adjacent over hypotenuse, the adjacent is down here, and we don't know that, but how would we find that? We would again do the Pythagorean theorem. So I'm going to label that b, and we have x squared plus b squared equals 1 squared. 1 squared is just 1. So I'm going to move the x squared over. We have b squared equals 1 minus x squared, and then your last step is to take the square root. So b, that adjacent side, is the square root of 1 minus x squared. So I'm going to write that up here, 1 minus x squared. And then we are ready to answer that question. The cosine of theta is adjacent, which is square root of 1 minus x squared, over hypotenuse, which is 1. So I'll just write it as the square root of 1 minus x squared. Okay, and that should be enough to help you with 30 through 32, but you can always let me know if you have any questions.